This is the structure question. Let's discuss the answer. Number one, this is all about a student has a stack of 20 identical coins, and this is the diagram of the experiment. And then you can see with his eyes at the position shown like this, the student measurement of the height of the stack is 6.8 centimeter. From the list below, is it environmental error, zero error, parallax error? State two names of the errors that the student did due to position of the eyes. Usually position of the eyes is parallax error. So this one is supposed to be answer for number one. Okay, number two, position of the zero of the ruler, that is the zero error. Yeah, that's why this one and this one is the answer. Why environmental error is wrong? Because that is usually because of the condition of the environment. And then supposed to be, which position is correct? The position is supposed to be here. The eyes must be aligned with the edge of the measurement or the measured object. That one. This is supposed to be the correct position of the eyes. Okay, now avoiding those two errors, another student's measurement of the height, this one. So this is actually the correct measurement. And then what is the thickness of one coin? Remember, this is actually for the whole coin, which is 20. So to get the answer is just 7.4 divided by 20, right? Please grab your calculator. 7.4 divided by 20, that is 0.37. What is the unit? Follow the unit. 7.4 centimeter, so this is 0.37 centimeter. Using a different method, the student can measure the thickness of a coin accurately using another instrument. So you can see here, this is a ruler. There is more apparatus that can take more accurate or more precise, which is actually vernier caliper and micrometer screw. For the vernier caliper, usually the reading must be in centimeter. For the micrometer screw, the reading will be in millimeter. For this one, you can see since the thickness is in centimeter and it's 0.37, you can use either the vernier caliper or micrometer screw, as long as it is actually more precise or more accurate than the ruler. So you can write vernier caliper. You can also write micrometer screw. You can also write the full name, micrometer screw gauge. What is the one that is less accurate or less precise than ruler? That is actually usually, what is it? Meter rule, correct. And then what else? Measuring tape. They are less accurate compared to the vernier caliper and the micrometer screw. Okay, the next one, the student measure the mass of a coin. When the balance is empty, it shows 0.1 gram. This is the zero error. Yeah, and you can see this is positive, right? So that is positive, zero error. And the shown 2.5 gram is actually with the zero error. So what is the correct one? 2.5 minus 0.1, which is supposed to be 2.4. Don't forget the unit, 2.5 gram, 0.1 gram. So this one supposed to be gram 2. Now E. Another coin has a mass. So this is a mass, and the mass is in gram. And the volume, this is the volume. Calculate the density in kilogram per meter cube. My suggestion, you find the density in gram per centimeter first. Yeah, gram per centimeter cube. So it's mass divided by volume, that is density. The mass is 2.7, the volume is 0.5. So use the calculator. 2.7 divided by 0.5 is 5.4. And this is in gram per centimeter cube. If you want to convert it into kilogram per centimeter cube, you have to times by 1000. This one. So you can write either 30.4000, or you can use the scientific notation 5.4 times 10 to the power 3 kilogram per meter cube. This is the one that you really have to use, yeah. You have to be able to use this scientific notation. That one. Okay, now the next, the coin is put into the liquid and it sinks. Now if the object is sinks, usually the density of the coin is larger than the density of the liquid. Okay, remember we have three positions of the object. This is when the object floats, when it is the surface of the liquid. It can be above it, can be like this, as long as what happen it's near the surface. We call this float. And if it is the float, usually the density of the object is smaller than the density of the liquid. If the object sink here, we call this condition sink, when the density of object more than the density of liquid. If the density or the position is here, we call this submerge. Submerge means when both density are equal. This one. That is for the question number 1. Okay, now it's the second question. For the second question, a large stone initially at rest fall from the top of the building. So you can draw the building first, like this. Then we have the stone. The stone takes 4 seconds to fall to the ground. So from the top of the building downward is actually 4 seconds. For this stone, air resistance can be ignored. So there is no effect of the air resistance to the falling of this object. State the acceleration of this falling stone. If there is no air resistance, the acceleration must be the acceleration of the gravity. Since the question doesn't say anywhere, this is actually on Earth. So the acceleration of free fall on the Earth is 9.8 meter per second square. Calculate the speed of the stone just before it hits the ground. So since it has the acceleration, sir, can we use the speed is distance over time? Cannot. Why? This is when there is no acceleration, or the acceleration is 0. So if you have acceleration, or the acceleration is not 0, you have to use this equation, which is acceleration final speed minus initial speed divided by the time. When you have to change the equation, then it will be v equal to u plus at. This is if the object accelerating. Then if the object is decelerating, remember decelerating means the acceleration is negative, so the equation will be v u minus at. Okay, so we're gonna use this equation, right? So v equal to u plus at. Now it's free fall or not? Okay, initially at rest. So initial speed will be 0. So this is 0. What is the A? We got the A already in the previous question. So 9.8. And what's the time? The time is 4 seconds. So it's times 4. Then, what is it? It's just using the calculator, right? 9.8 times 4, which is 39.2. For the IGCSE, just two significant figures, so just 39. And its speed, the unit is meter per second. So 39 meter per second. Okay, next question. On the figure 2.1, which is in here, the speed time graph, you have to draw it for the stone. This one. Label it with the X. Okay, now the object accelerating and the acceleration is constant. Because what happened? We ignore the air resistance. So the air resistance will be, the acceleration will be constant. Now in the speed time graph, acceleration will be the gradient. So you have to draw the speed or plot the speed from 0 until the time is 4. Okay, how do you know what's the speed when the time is 4? This one. When the time is 4, this is the speed. So 39. 39 means where? This one. Okay, initially start from 0, right? So when the time is 0, the speed is 0, this one. So what should you do? The gradient constant means just a straight line. So from here, there. Sorry, I don't have the, what we call it. I don't have the ruler, so I have to draw it carefully. Here, there. This is supposed to be straight. In your exam, please use the ruler. Okay, and then do you have to label? Yes, you have to label this with the X. So label this X. You can label it here at the end. You can label in the middle. And just choose one. Okay, now the next one, B. A book of similar mass. A book with similar mass, which has a greater cross-sectional area, that the stone in A falls from the same building at the same time as a stone fall. This book is affected by the air resistance. Remember, if there is air resistance, what happens? If we have more area or more surface area, there will be more air resistance. Then what's the effect? The acceleration will decreases. So, explain the difference between the book and the stone motion. Remember motion. Okay, for the motion, you can talk about what? The speed. You can talk about the acceleration. Even you can talk about the falling time. So, is that a different? Yes. What happened? The book has larger, what do we call it? Larger area, right? So the book acceleration will be smaller than the stone. Because what happened? As you can see, more air resistant, the acceleration will decreases. You can also talk about the speed. The speed of the book when it hit the ground will be smaller than the stone. On the figure 2.1, draw the possible speed of this book. Remember, the book is affected by the gravity, right? The book is affected by the air resistance, so acceleration decrease. Remember, in the speed time graph, acceleration is the gradient. So what happened with the gradient? Yeah, it will decrease. Initially, it's straight, but then after that, because why straight? Because initially the acceleration is 9.8. When it fall longer or it fall further, then the acceleration will decreases. So the gradient will decrease. That's why the gradient decreases, yeah. Not straight anymore. It's curve. So like this. And you have to label it with Y. So label this one with Y. That is the end for question number 2. Okay, it's question number 3. We have the mass. This is train, so this is the mass. And initially at rest, so initial speed is 0. When the time is 0 second, a resultant force acts on the train and it starts to accelerate forward. Now, you have to define the weight. Weight is really easy. Why is that? Weight is pull of the gravity. Weight is the pull of the gravity. Now, you have to calculate the weight. Weight equation is mass times gravity. So what's the mass? 5.6 times 10 to the power of 5. The gravity, which is the gravitational field strength on Earth, is 9.8. Why on Earth? Because it doesn't say so. So it's supposed to be on Earth. If it doesn't say any planet, that means it's on Earth. So 5.6 times 10 to the power of 5. And then you times it with 9.8. You will get 5.5 times 10 to the power of 6. Yes, so that's the answer. 5.5 times 10 to the power of 6. For the weight, the unit is the same as the unit of the force. So it's Newton. Initial acceleration. So this is the acceleration. Calculate the resultant force. Remember, resultant force is, if you have acceleration and mass, it's mass times acceleration. Mass is 5.6 times 10 to the power of 5. The acceleration is 0.75. So using the calculator, 5.6 times 10 to the power of 5 times 0.75 is actually 4.2 times 10 to the power of 5. So it's 4.2 times 10 to the power of 5 Newton because it's force. Okay, now spring P has spring constant 100 Newton per centimeter. That is the K, spring constant. And obey Hooke's law. In the Hooke's law, what is this? Force is directly proportional to the extension. So that's it. So you can say in the Hooke's law, force is directly proportional to the extension. Okay. Now, the spring P is pulled by 50 Newton force. So this is the force. So what is this? This equation will change into force equal to K times X. And the K is the spring constant. So you have to find the extension, right? So X will be equal to force divided by the K. The force is 50 and the K is 100 Newton per centimeter. So if you use 100, then what happen? This result later will be in centimeter because the unit of the spring constant here is centimeter. But if you later have the spring constant in meter, then that's supposed to be meter, the extension. So 50 divided by 100 is actually 0.5. So this is 0.5 centimeter. Okay, now the next one, what is? Spring Q has a greater spring constant. And then you have to describe an experiment to prove it. Usually, we hang the spring like this. Okay, we hang the spring. So let's say this is spring P, this is spring Q. And then Q has greater spring constant, right? Remember what happened? Spring constant, you can get it by using the Hooke's law. Before, what's that say? Force is equal to K times X. So X will be equal to F divided by K. You can see what happened, guys. K is directly proportional to the F because you see the position, they have the same position. But for the K and X, spring constant is actually directly proportional or inversely proportional. Inversely proportional to the extension. So actually we can use this one to see what happened. Which one has more spring constant? That means it's opposite with the extension. The extension will be less. This will be okay if the force is constant. So both of them, P and Q, you have to pull them with the same force, like this. So this is force, yeah, or you put the mass, right, and you can find the weight, that will be the force. The force must be the same. So what is it? Is it compulsory for you to draw? No, because this is MYE. Yeah, even you don't draw it, it's okay. But usually drawing will help you to make the procedure. Okay, so now what should you do first? Of course, you have to hang, right? Hang to object. So you have to say hang to spring P and Q from a little stand. After that, what happened? Do you have to measure first the initial length of them? Sure. You can actually do the, what we call it, measurement of the initial length when the spring is on the table or when there is no force. You can also use this one. So you can use ruler, right? Of course, use ruler, measure the initial length of both springs. That's the next step. What's the next step? You have to hang or add the same weight or mass. Also, you can say mass of loads to both springs. Yeah. After that, what should you do? you have to measure the final length. So use ruler, measure the final length of both springs. Yeah, you have to use the ruler. The last one, find extension of both springs by, what should you do? By subtracting the final length with initial length. That's it. Or not yet? Not yet, because what happened? You have to prove that Q has greater spring constant. Many students think this is finished. Not yet, guys. Yeah, you have to now compare the extension. If, right, it say Q has greater spring constant. Yeah, so you have to prove it. Since Q has greater spring constant, remember, we have to use this relation. So what happened? Its extension will be less than that of P, which is the extension of P. That's supposed to be the correct and complete answer. Okay, that is question number 3. Okay, now it's question number 4. Briefly explain the following statement. Momentum is a vector and time is a scalar. Remember, vector and scalar, the difference is only the direction. So you can say momentum, if it is vector, momentum has both magnitude and direction. Both of them. For the scalar, since time is scalar, you can say time only has magnitude. You don't have to talk about the direction because scalar doesn't have it. Or you can say time doesn't have direction, only magnitude. You can also do that. Circle all scalar. Now, anything that doesn't have direction is scalar. Weight is what? Weight is actually force. So this is vector. Speed is actually scalar because the one that has the direction is velocity. That's why velocity is vector. Mass doesn't have direction, only weight that has direction. So mass is scalar. Acceleration has direction. It depends on the force. So acceleration is supposed to be what? Vector. Energy doesn't have direction, so this is scalar. Distance is like displacement. We're talking about length, but distance is scalar, while displacement is vector. Tension is actually force. It's one type of a force, so tension is the vector. So you have to circle all scalar: speed, mass, energy, and distance. Okay, this is for the question about the drawing vectors, right? So figure 4.1 show two forces acting on an object. You can see this is 20 Newton and the direction is actually 30 degree from the vertical and 15 Newton is downward. And make sure it's not to scale. That's why you can see actually the length of 20 Newton and length of 15 Newtons is similar. They're supposed to be not, because the directions is indicated by the arrow, but then the length of arrow indicate also the magnitude of the forces or the vector. Draw a scale diagram to determine the resultant force acting on the object. State the scale you use. You can see here on the final answer, you have to set the scale. 1 centimeter in your drawing is equal to how many Newton? And then magnitude of the resultant force, of course, later will be from your drawing and supposed to be in Newton. For this one, I will show you there is two ways. Number one is you have to draw the first vector and then put the second vector in the end of the first vector. The second one is you can use the drawing parallel lines to each other. Okay, now for this one you need the ruler. Yeah, you need the ruler, because what happened, we have to draw the scale diagram. So the length of the arrow also important, and we also need the protector because we need to measure the 30 degree. Now which one that you want to do first? For me, I would like to make sure the 30 degree factors, I'm sorry, that is the 20 Newton factors, that's supposed to be the first factor. So what should you do first? You don't have to draw first. You have to determine the scale. So this 20 Newton, you want to make it into how many centimeter? What about, yeah, let's check first. This is 1 centimeter, okay, equal to how many? Yeah, maybe 5. Yeah, 5 Newton. Okay, so that means what happen if you have 20 Newton, 20 divided by 5 supposed to be 4 centimeter, and for the 15 Newton that will be 3 centimeter. Okay, that's why right on the bottom 1 centimeter is equal to how many? 5 Newton, like this. Okay, now let's do the first one. So we have to draw the what we call it, vertical line first. Yeah, so we draw the vertical line here. Okay, we draw the vertical, and then after that we have to take the protector, because what happened, the 20 Newton supposed to be 30 degree from the vertical. So this one, and 30 means will be from here, right? We start from this one. So 30, 1, 2, 3, this one. While this is the center. Okay, now we have to draw the what? The arrow. Yeah, the arrow supposed to be how many? Supposed to be how many centimeter? For 20 Newton, it's supposed to be 4 centimeter. So let's do 4 centimeter upward. Okay, I'm gonna use the drawing, it's good, right? So from here upward until this one. Okay, so that is the 20 Newton. So this is 20 Newton, and it's 4 centimeter already. Okay, the next one is you have to draw the 50 Newton from the end of the 20 Newton. Yeah, so we have to make sure this one straight and then going down. Yeah, how many centimeter? For 50 Newton, based on our scale, it's supposed to be 3 centimeter. So you go down from here, okay, 3 centimeter. Let's draw it. Like that. Yeah, that's supposed to be 3 centimeter. Don't forget the arrow, indicate the direction. So where is actually the resultant? Resultant supposed to be from the very beginning, this one, to the very of the end, which is this one. Then you have to use the ruler again to connect these two dots. Okay, like this, right? I'll tilt a little bit. Okay, there you are. So let's draw it from the very beginning to the very edge. One. Don't forget, since this is what do we call it? Resultant force, so supposed to be double arrow. Don't forget also to label the 15 Newton downward. Like this. Now, how do you find the magnitude of resultant force? You have to measure first. So this one, okay, this one, how many centimeter? So we have to move this ruler first from 0 until that. So how many centimeter? So this 2.1 centimeter. Okay, remember, we have actually the scale, right? 1 centimeter is equal to 5 Newton. So if it is 2.1 centimeter, that is 2.1 times 5 Newton. What is that? 2.1 times 5. 2.1 times 5 is actually 10.5. That's why the answer for this one is 10.5 Newton. Cannot centimeter because it's a resultant force. So it's supposed to be 10.5 Newton. Don't forget the unit, yeah, Newton. So this is what we call first method. You draw the first factor, draw the second factor after the first factor. The other one, what is this? You have to draw the same. Okay, the first factor first. And the second factor must be from the beginning of the first factor. So basically, you just have to copy and paste the arrows with the correct length. Okay, so let's do it again, shall we? Okay, first we draw the vertical line first, dash line. Okay, let's go. Okay, and we start from this one for the first factor. So we use the protector here. What's the angle? 30. So 1, 2, 3, 10, 20, 30 here. Okay, and after that we can use this one, just copy paste. You have to do it manually. This one. Okay, the length supposed to be the same. How many before? 4 centimeter. So that is the first factor. And the second factor, you have to draw how many centimeter? 3 centimeter downward. So it's 3 centimeter downward from here. Okay, the same initial position as the first factor. That is the second factor. Oh, let's repeat that. I will erase this one first, because we have to make sure it is straight, right? Okay. This one, the ruler. Make sure it's 3 centimeter downward. Okay. Go down. Like that. Yeah. This is the... sorry, it's not straight, but it's supposed to be straight. So this has 20 Newton. This is 15 Newton. Then you have to draw the parallel line. Okay. How do you draw the parallel line? You can do the parallel line to 15 Newton. Yeah, at the end of the first factor. Draw the parallel line. How long? It's okay, as long as you can. And then after that, we have to draw the parallel line to... which one? Yes, the parallel line to the 20 Newton. So let's do the 20 Newton. Make sure it has the same direction. Not yet. Okay, like that. So we have to put the parallel line at the edge of the 15 Newton. So let's do it. Parallel, 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 parallel. Okay, then what happened? You can see these two parallel line is intersect here. So that is supposed to be the end or the edge of the resultant factor. So let's do it. Right, so this is from that to that. So we will draw it like this. Actually, I don't know what happened. Yeah, the direction supposed to be the same. The length supposed to be the same also. Yeah, it's around 2.1. In here it's 2, but if the direction is correct, supposed to be 2.1 also. The final step is the same. The result of your measurement of the resultant force or resultant factor, how many is the centimeter? 2.1, and then times the scale, 2.1 times 5, which is 10.5 Newton also. Yeah, these two methods supposed to be the same, the result. It's up to you. You want to use the first method or second method, it's okay, because the result also the same. That is the answer. Okay, it's question number 5. State what is meant by the moment of a force. Moment is of a force Remember, moment has this formula: force times perpendicular distance. Yes, it's supposed to be perpendicular distance, and you have to expand. The distance is actually from where to where. That's why you can say just like this: force times perpendicular distance from from object, or from the force? From the force, yeah. So from the force to the pivot. Remember, pivot is a point that doesn't move when the object rotates. Now, complete the following statement. Turning effect of a force is called what? It's called moment. And the unit is, what's the unit? It's actually, since it's force times distance, force unit is Newton and the distance is meter. You can write Newton meter or Newton centimeter. Yeah, it's okay. As long as correct unit for the force, which is Newton, correct unit of the distance can be meter or centimeter. Okay, now next. A uniform meter ruler is pivot at a center. This is the pivot. Is it always in the center, the pivot? No. But in this question, yes, it is in the center. Now, the three loads, 3 Newton, this one, 2 Newton is this one, and F is here. Yeah, right? The force F maintains the meter ruler in equilibrium. What is equilibrium? Equilibrium is a condition when it's satisfies two conditions or two criteria. What's that? Resultant moment is 0. So resultant moment 0 means clockwise moment will be equal to anti-clockwise moment. And resultant force will be equal to 0. Now for this one, in this kind of question, you have to find the unknown force, right? It's better to use the resultant moment equal to 0. So what's resultant moment is 0? Total, yeah, this is total anti-clockwise moment equal to total clockwise moment. You have to analyze first which force that will make the object turn clockwise and which force that will make the object turn anti-clockwise. How do you do that? You can use your pencil. Since the pivot here in the center, just put your finger in the center, right? And then look at the 3 Newton here. 3 Newton here is downward. So you put another finger with your other hands, of course, then pull it downward. So what happened? It will make the object, the beam or the ruler here, move the anti-clockwise. So this will be one of the anti-clockwise moment. What about the 2 Newton? The same method. Pull down, but now it's on the right of the pivot. So this will actually move clockwise moment. And this one, the F will be also becoming clockwise moment. Okay, so what is moment again? Moment is force times distance. Now, in this one, we only have 3 forces, so there will be 3 moments. And the only anti-clockwise moment is the 3 Newton. That's why total anti-clockwise moment only 1. Force times distance. For the total clockwise moment, we have 2, yeah? So you have to add them. Force distance times force distance. Now, what is the force for the clockwise moment? It's 3 Newton. And what's the distance? Be careful, guys. The 10 centimeter, 50 centimeter, 70 centimeter, 80 centimeter, 100 centimeter, and 0, that's indicate the mark on the ruler. Do you have to use that number? No. Remember, force times distance, and this distance must be perpendicular and supposed to be from the force to the pivot. So if the force is 3 Newton, that's the position of the force, and the pivot is here, right? So what's the difference between them? It's from 10 centimeter to 50 centimeter, 40 centimeter. So it's 40. Can you convert it into meter? Can. It's okay. But I don't want to convert it. Because what happened? We have distance on the left and on the right. If the distance unit is the same, it's okay. Because what happened? We just have to find the force anyway. So the next one, for the 2 Newton, that's the force. The distance is from this one to this one. What's that? 20 centimeter. So I times 2 with 20. And then the next one, we have the force, right? And the distance is, what's that? Don't say the distance is from 70 to 80. No, it's supposed to be always from the pivot to that force, which is from 50 to 80. What's that? 30 centimeter. So this is F times 30, like this. So at the end, we're gonna have 30F is equal to 120 minus 40, right? So the F will be how many? So 120 minus 40 divided by 30. So it's 2.7. Yeah. So the F will be 2.7 Newton. If you're still confused how, just like this. So the F will be 120 minus 40 is 80. The 30 move to the right, become divided. So like that. So the F is 2.7. That is the answer for number 5. Okay, now it's question number 6. Question number 6 is a power station burns waste material from the farm crops. Farm crop is actually the waste produced by the farm, which is this supposed to be made of the plants. State and explain whether this process is renewable or not. This is, of course, renewable. Why? Plants, if you use the plants and then to produce electricity, that is actually becoming biomass or biofuel. So biomass or biofuel is actually renewable. So you can say it is renewable since they become biomass. And what happened? You can get it again after you finish harvest, right? You always get the farm crops. So you always have this one. And then B, burning waste material makes 250 kilograms. So this is the mass. Turbine move at 40. So this is the V, the speed or the velocity. The turbine has a place 5 meter above the ground. So this is actually what? The height. Okay, state the name of energy possessed by the turbine due to the position. Remember, yeah, it's not because of the movement. It's a position which has to refer to 5 meter. So what's that? It's GPE because it has height, so it's GPE. Now you have to find the kinetic energy. Kinetic energy equation is a half mv squared. The mass is, what's that? 250. And the speed is 40. So be careful again. Many students forget that they have to square the speed. It's supposed to be square. If not, then it's wrong. So 40 square. The answer for this one will be 200,000. You can write 2 times 10 to the power of 5 joule. This is energy. That's why the answer is joule. Okay, the turbine generate 75,000 joule of electrical energy. This energy is actually energy that you use, right? So that's, we call this useful energy. You have to find efficiency. Efficiency symbol is eta. So eta will be useful energy. Useful output, of course. Now, energy or power, sir, depend. The question, we have the data of energy, so you have to use energy. Useful output energy divided by total input energy. And always times with 100% because efficiency unit doesn't have unit but it has percent. So useful output energy is what? It's the one that is generate electricity, which is 75,000, right? For the input energy, it's actually 200,000, and then you have to times 100%. So 75,000 divided by 200,000. What's that? 37.5. You can run up into 38%. Okay, now another power plant use fossil fuel produce more electrical energy. Environment consequences. What's that? Consequences usually can be positive, can be negative, right? For the fossil fuel, you can also discuss about the negative consequences. Number one, what happened? It emits carbon dioxide. Carbon dioxide, carbon monoxide, this is actually contributed to the climate change. So number two, what happened? Increase climate change. You can say increase climate change, you can say also increase global warming, can be also. That is the answer for number 6. Okay, now it's for the question number 7. The question number 7, a round bottom flask. Which one? This one. Connected to U-shape, this one is the U-shape, containing mercury. The air inside of the flask is warm. So you make this one warm, then you can produce the different height of the mercury level. State the name of this U-shape is actually manometer. Isn't barometer? No, barometer will be have like this. You have another tube, this one. And then there must be different mercury level or liquid level. This is the barometer. Manometer is basically used to find the difference in the pressure between the two gases. And here we have air inside the round bottom flask, and this one is actually the atmospheric pressure. Yeah, because it's open to the atmosphere. Okay, now based on the figure 7.1, state and explain which gas inside the flask has more pressure. So which gas? Yeah, atmosphere, which is outside, or the air inside the flask. Now you can compare the height of the mercury level. This one is go down, this one go up. Why this side is go up? Because the air push more. The air inside the round bottom then has more force, more pressure. So you can say it's the air inside the gas. You have to explain why. Because the mercury level is lower due to more force. Yeah, it push more, so the mercury level go down. C, atmospheric pressure 760. So this one is 760 millimeter of mercury. Now, what about in here? Okay, remember, if you want to find the what we call it pressure, that's supposed to be the pressure is greater, yeah, pressure of the other one, which is in here PATM, plus the difference in pressure. How do you get the difference in pressure? You got it from this one, the difference of the mercury level. What's the difference between this one to this one? So this is 220, this is 380. What's the difference? 160. Yeah, so PATM 760 plus 160. Hold on first. What happened? You have to make sure the unit is the same. So 760 millimeter, right? And in here also it's millimeter. So it's okay. It's correct. So what's that? 760 plus 160, which is 920. And you can see it's in millimeter also. So that's the answer. 920. Okay, now state what will happen to the height difference between liquid surface when the atmospheric pressure increase while the gas pressure is constant. So the manometer, right? So what happened? Now the atmospheric pressure push more. So what happened? It will go down. This is constant, right? So even it's constant, it's gonna be weaker than before. So what happened? This will be going up. So the height right now is actually decreased. Because what happened? The ATM is going down because push more. This one will go up. Okay, so what happened to the height different? You can say decreases. Do you have to explain the reason? No, only state. Mercury is replaced with the less dense liquid. If it is less dense liquid, what happens? It's going to be easier to push, right? Do we combine the atmospheric, the I with the double I? No. It say what happened? It's still mercury. Right now the gas, inside the vacuum flask still has more pressure than the atmospheric pressure. But then it's gonna be easier to be pushed, because it's less dense. So what happened? It's gonna be really low. For the PATM, it's gonna be really high. So the height right now will increase. That's why the answer for this one is increases. That is the answer for question number 7.